OK. Bonjour, je m'appelle Samantha Bayard, je suis la porte-parole d'Environnement Changement climatique Canada et je serai la modératrice de la séance d'information et point de presse sur les prévisions saisonnières de l'hiver et une nouvelle fonctionnalité du système d'attribution des phénomènes météorologiques extrêmes. Je tiens tout d'abord à souligner que je vous adresse aujourd'hui depuis le territoire non cédé de la nation algonquine-anishinaabe. Avant de commencer, j'aimerais soulever quelques points. La présentation sera d'abord en anglais et sera suivie par une présentation en français. Nous passerons ensuite à une période de questions. Madeleine Sorcel, spécialiste des phénomènes climatiques extrêmes, et Jennifer Smith, météorologue nationale en préparation aux alertes, feront une présentation au nom d'Environnement Changement climatique Canada. Leur présentation et la période de questions et réponses peuvent être enregistrées et sont destinées à être attribuées. Pour être sollicité, assurez-vous que votre nom et votre média soient clairement identifiés dans votre nom Zoom. Veuillez vous en tenir à une seule question et une question de suivi. Et les journalistes peuvent régler le ratio entre le présenteur et la présentation à l'aide d'une barre glissante située au milieu de l'écran. Hello, my name is Samantha Bayard, spokesperson for Environment and Climate Change Canada. And today I'd be moderating today's information session and media availability on seasonal overview for winter and a new feature of the rapid attribution system for extreme weather events. I would like to begin by acknowledging I am coming to you today from unceded territory of the Anishinaabe Algonquin Nation. A few points before we begin. The presentation will occur first in English and be followed by a presentation in French. We will then move to a question and answer period. Dr. Madalena Sorcel, Climate Extreme Specialist, and Jennifer Smith, National Warning Preparedness Meteorologist, will be presenting on behalf of Environment and Climate Change Canada. This information can be recorded and is for attribution. To be called upon, please make sure your name and your media outlet are clearly identified in your Zoom name. In the interest of time, keep it to one question and one follow-up. Reporters can adjust the ratio between the presenter and the presentation using the sliding bar in the middle of the screen. For the Q&A, there'll be no presentation as well, just people. Okay, on commence.
Hey. Good day, everyone, and welcome. Thank you for joining. Today's talk begins with a walk through Canada's winter outlook, which spans December through February. But before we get into the weather story, let's briefly talk about seasonal outlooks in general. Next slide, please. Seasonal outlooks look at the big picture trends, such as whether temperatures and precipitation are most likely to be above, near, or below average. They're based on probabilities and not guarantees. It's important to remember that these forecasts cover 3-month periods and not day-to-day weather. So they can't tell us how much snow will fall or when a specific storm will hit. Those are really only predictable at most about a week out. Even so, these outlooks help communities prepare for what's likely in the months ahead. And one clue this winter is that a weak La Nina is expected to play a role. But first, let's take a quick look back at the fall season. Next slide, please. It was a fall that really didn't feel like fall at all. It was remarkably mild almost everywhere in Canada. That warm backdrop made winter's abrupt start feel especially sharp and much colder than Canadians have become accustomed to in recent years. There were some exceptions. BC, southwestern Alberta, and Baffin Island all saw above seasonal temperatures continue into December. With this in mind, let's look at what winter might bring through the season as a whole. Next slide, please. At first glance, the warm colors stand out right away. The strongest signal for above average temperatures is across the eastern Arctic, around Hudson Bay, across northern Quebec, and Labrador. These areas are coming off an already much warmer than normal fall, and the signal is forecast to continue into winter. Some regions, like parts of the Yukon, the Northwest Territories, and Western Nova Scotia, could see below seasonal temperatures. Others, such as the west coast of BC, eastern Nova Scotia, and central and eastern Newfoundland, lean closer to near average. Keep in mind that the colors are very light, indicating lower confidence. Furthermore, most of the map is white, and that means confidence is low, and any of the three outcomes are possible. All of that said, day to day, Canadians will still experience the full range of winter weather. Those bone chilling cold snaps we've already seen in early December, thanks to a less stable polar vortex and a wavier jet stream, along with milder stretches mixed in. But when all the days are averaged together at the end of the season, the clearest signal is a milder eastern Arctic. Beyond that, uncertainty takes over. So staying informed is your best tool. Next slide, please. Precipitation is always tough, the toughest part of the seasonal outlook, and confidence is generally lower here. But there are still a few clues. With a weak La Nina in place, we often see storms tracking from the Yukon down across the Rockies and parts of the prairies and then into the western Great Lakes. That classic storm pathway is where we lean above average for total precipitation this winter. Further east, things are less clear. The forecast shows equal chances of above, near, or below average precipitation. Something else to keep in mind is that the Great Lakes and Hudson Bay, James Bay all started the season warmer, meaning there is ample moisture to feed into snow squalls, for example. Those events are highly localized, but can be intense, especially early in the season before the lakes and bays begin to freeze over. And of course, winter storms that originate in the US, such as Colorado lows, Texas lows, nor'easters that form off the Carolinas, can all make their way into Canada. Depending on the exact track, they can bring major impacts to southern Ontario, southern Quebec, and Atlantic Canada. All in all, Canadians are no strangers to winter. And while this one is off to a classic cold and snowy start across much of the country, it's a complex season with a lot of competing forces. We'll be keeping a close eye on how things evolve in the months ahead. I'll now pass things over to my colleague, Dr. Madalena Sarcel, to talk about the ocean and climate change and how they factor into this year's outlook, and to share some exciting new research news. Over to you, Madalena.
Thank you, Jennifer. I will now discuss the role of the ocean on the seasonal forecast. As you just heard, Canada's winter is expected to be cooler and wetter in some regions and warmer in others. I am showing here a map of global sea surface temperature anomalies, differences from normal. There are three patterns of importance here. First, we are dealing with a weak La Nina. This is the fifth La Nina event in the last 6 years. It manifests by cold sea surface temperature anomalies in the equatorial Pacific. Then we have the negative phase of the Pacific Decadal Oscillation, the PDO, shown here by warm anomalies in the interior Northern Pacific. Finally, we have warmer than normal sea surface temperature in Hudson Bay and around the Northwest Atlantic. The first two factors affect mostly Western Canada, even though their effects can extend all the way to the Great Lakes. They result in wetter and cooler winters in the west and could lead to more lake effect snow over the Great Lakes region. The third factor, the warmer than normal sea surface temperatures, lead to delayed ice progression and also warm coastal temperatures over Hudson Bay and the Northwest Atlantic region. This third factor is a manifestation of the long-term warming climate trend and not related to La Nina or the PDO. Next slide, please. In terms of the long-term warming trend, I am showing here a plot of average winter temperatures over Canada between 1948 and 2025. What we see from this plot is that the average winter temperatures have increased by 3.7 degrees over that period. This warming trend is always a backdrop of any seasonal winter forecast, partially offset by the cooling effect of La Nina in the PDO. The global warming trend means extreme cold events happen less often and are warmer or less intense. Next slide, please. I will now turn to Canada's rapid event attribution system, which we use to determine the likelihood of extreme temperature events like cold snaps and heat waves, and how they are affected by our warming climate. Now, in a new pilot system, we can also do extreme precipitation, most of which falls as heavy rainfall over Canada. Extreme precipitation events are expected to become more frequent and more intense due to human-caused climate change, as a warmer atmosphere can hold more moisture. However, as we can see from the map of average precipitation amount on the wettest day of the year, extreme precipitation amounts vary across the country, depending on the weather system that causes it. Over the Pacific coast, a region affected by atmospheric rivers, the maximum daily precipitation can surpass 200 millimeters a day in some locations. Eastern Canada and the maritime provinces, where the most intense storms are mid-latitude cyclones or post-tropical cyclones, can also receive high rainfall amounts. On the other hand, in the Canadian North, the average wettest day can be as low as 10 millimeters per day. It is therefore very important to consider this geographic variability. Next slide, please. The Canadian Rapid Event Attribution System determines how the frequency of extreme weather has shifted over the last 150 years because of human activity. This is done by using climate model data to calculate how the chance of occurrence of an extreme event in today's climate with the influence of human activity compares to the chances of this event happening in the pre-industrial climate before human-caused climate change. This is illustrated in the diagram on the right for hot extremes. The current climate, represented by the red curve, is shifted towards warmer temperature than the pre-industrial climate, the blue curve. Therefore, an event of a certain magnitude would happen more often in the current climate than in the pre-industrial climate. So the shaded area under the red curve is larger than the shaded area under the blue curve. Next slide, please. So once we calculate the change in the likelihood of the event occurring between the current climate and the pre-industrial climate, we express this result as a likelihood statement. For example, if an event is 2 to 10 times more likely to occur because of human-caused climate change, we say that the event is much more likely to occur. The warm colors on the dial correspond to events whose chance of happening increases due to human-caused climate change, such as heat waves or extreme precipitation events. On the other hand, the cold colors correspond to events that are less likely to occur due to human activity, such as cold snaps. Expressing the information the system provides in terms of simple statements gives Canadians direct insight into how climate change is affecting our lives and weather today. Next slide, please. So similarly to extreme temperature events, the precipitation events are analyzed over predetermined regions. However, given that precipitation extremes happen on smaller spatial scales than temperature extremes, the precipitation system uses 89 smaller regions nested within the 17 regions of the temperature system, showed here on the map on the right. While the most extreme precipitation over Canada is heavy rainfall, in its current pilot form, the system is considering all precipitation types, so rain, sleet, snow, freezing rain, and hail, all together due to the observational and the model data that we now use. The system runs every day and the results are available the day after the event. Next slide, please. So, as an example of how the system works, we present a heavy rainfall episode caused by the passage of Hurricane Melissa over eastern Canada. You can see here maps of daily precipitation over eastern Canada for October 31st and November 1st. The system compares the average amount of daily precipitation over each region, depicted in the maps below, to the climatological value of extreme daily precipitation over that region. If the climatological value is surpassed, an event is detected and the attribution study is performed. If the climatological value is not surpassed, we do not have an extreme event. For the Hurricane Melissa rainfall, the threshold was surpassed over 3 regions, resulting in extreme precipitation events being detected on October 31st and November 1st over south central Quebec, Saguenay-Lac-Saint-Jean, and eastern Labrador, Happy Valley Goose Bay. The attribution analysis of these 3 events show that the events in Quebec were more likely to occur due to human-caused climate change, while the Labrador event was much more likely to occur. Next slide, please. So the pilot precipitation system has now been running and providing attribution results since June 2025. We have compiled a total of 42 events over various regions within Canada, as you can see on the map here. From these events, 3 were much more likely to occur, while the rest 39 were more likely to occur because of human-caused climate change. We will continue to monitor extreme weather events using this system. This area of research supports important decision-making that helps Canadian communities prepare for and adapt for the changing frequency and severity of the extreme weather events. With this, I will pass back to Jennifer. Thank you very much for listening.
Great. As we come to the end of our session, I want to take a moment to highlight our new color-coded alerting system. We've updated the way we share weather alerts with Canadians to make them clearer and more helpful. Our color-coded alerts focus on what the weather will do, not just what it will be. They highlight the potential impacts of severe weather and help guide you on how and when to take action to protect yourself, others, and your property. To stay on top of changing conditions, you can download the WeatherCan app for real-time notifications or check the latest alerts anytime at canada.ca/weather. Next slide, please. As we wrap up, a reminder about staying prepared this winter. A few small steps can make a big difference during extreme cold or storms, for example. Ideas for staying safe include making sure you have an emergency kit ready, keep your devices charged in case the power goes out, get your vehicle winter ready, stay informed by following the latest forecasts and alerts, keep warm and limit time outdoors, especially during extreme cold, dress in layers and cover exposed skin, and don't forget to check in on neighbors, friends, and family. For more tips, you can visit getprepared.ca to help you stay safe and ready for whatever winter brings. Next slide, please. And with that, I just say thank you for your attention and stay safe and enjoy the winter season.
Okay, you can go. On peut continuer en français.
Okay. Bonjour à tous, à toutes et à tous, et bienvenue. Merci d'avoir rejoint cette présentation. Nous allons commencer par un aperçu des perspectives hivernales pour le Canada de décembre à février. Mais avant de plonger dans l'histoire météo, prenons un moment pour parler des perspectives saisonnières en général. Diapo suivante. Les perspectives saisonnières nous donnent une vue d'ensemble. Elle indique si les températures et les précipitations ont plus de chances d'être au-dessus, près ou en dessous des normales. À noter, ce sont des probabilités, pas des garanties. Elles couvrent des périodes de 3 mois, donc elles ne peuvent pas nous dire combien de neige tombera, ni quand une tempête précise se produira. La neige, on peut seulement la prévoir environ une semaine à l'avance. Mais malgré ces limites, ces perspectives aident les communautés à se préparer pour les mois à venir. Est un indice important pour cet hiver et qu'une faible La Niña devrait avoir un rôle à jouer. Mais commençons par un retour sur l'automne. Diapo suivant. Cet automne ne ressemblait pas vraiment à un automne. Il a été remarquablement doux presque partout au Canada. Ce contexte plus chaud a rendu l'arrivée soudaine de l'hiver encore plus frappante et beaucoup plus froide que ce à quoi la population canadienne était habituée ces dernières années. Les seules exceptions ont été la Colombie-Britannique, le sud-ouest de l'Alberta et l'île de Baffin, où les températures au-dessus de la normale sont poursuivies en décembre. Gardant cela en tête, en regardant maintenant ce que l'hiver pourrait nous réserver dans son ensemble. Diapo suivant. À première vue, les couleurs chaudes ressortent tout de suite. Le signal le plus fort pour les températures au-dessous des normales se trouve dans l'est de l'Arctique, autour de la baie d'Hudson, dans le nord du Québec et au Labrador. Ces régions sortent d'un automne déjà beaucoup plus chaud que la normale et ce signal se poursuit en hiver. Certaines régions, comme des parties du Yukon, des territoires du Nord-Ouest et l'ouest de la Nouvelle-Écosse, pourraient connaître des températures saisonnières sous les normales. D'autres, comme la côte ouest de la Colombie-Britannique, l'est de la Nouvelle-Écosse et le centre et l'est de Terre-Neuve, se situent plus près des normales. Garde en tête que les couleurs sont très pâles, ce qui veut dire qu'on a moins de confiance dans ces prévisions. De plus, la plus grande partie de la carte est blanche et cela veut simplement dire que la confiance est faible et que les 3 résultats sont possibles. Au quotidien, la population canadienne continuera de vivre toute la gamme de temps hivernales. Les vagues de froid très intenses, comme celles observées au début de décembre, causées par un vortex polaire moins stable et une courant jet plus ondulée, mais aussi des périodes plus douces. Et tout se situe entre les deux. Lorsqu'on fait la moyenne de tous les jours sur l'ensemble de la saison, le message est clair, est un Arctique de l'Est plus doux. Au-delà de ça, l'incertitude domine. Donc, rester bien informé devient essentiel. Diapo suivante. Les précipitations sont toujours la partie la plus difficile des perspectives saisonnières et la confiance est généralement plus faible, mais on a quand même quelques indices. Avec une La Niña faible, on voit souvent les systèmes dépressionnaires passer du Yukon, descendre vers les Rocheuses et certaines parties des prairies, puis remonter vers les Grands Lacs. Dans ce corridor classique, on penche vers les précipitations totales au-dessus des normales cet hiver. Plus à l'est, c'est beaucoup moins clair. Donc, la prévision montre des chances égales d'au-dessus, près et en dessous des normales. De plus, les Grands Lacs ainsi que la baie d'Hudson et la baie de James ont commencé la saison avec des températures plus douces, ce qui a favorisé un apport importante d'humidité alimentant, par exemple les bourrasques de neige. Ces événements sont très locaux, mais peuvent être très intenses, surtout au début de saison, avant que les lacs et les baies commencent à geler. Et bien sûr, les tempêtes provenant des États-Unis, les systèmes du Colorado, du Texas ou les nor'easters qui se forment au large des Carolines peuvent aussi remonter au Canada. Selon la trajectoire, elles peuvent avoir des impacts importants dans l'Ontario, le sud du Québec et l'Atlantique. Bref, la population canadienne connaît bien l'hiver. Et même si celui-ci commence comme un hiver classique, froid et neigeux pour une grande partie du pays, cela reste une saison complexe avec beaucoup de facteurs en jeu. Nous allons suivre l'évolution de la situation de près au fil des mois. Je vais maintenant passer la parole à ma collègue Dr. Madalena Sorcel, qui va parler de l'océan, du climat et de nouvelles recherches passionnantes. À vous, Madalena.
Merci beaucoup, Jennifer. Je vais maintenant vous parler de l'importance de l'océan pour les prévisions saisonnières. Comme vous venez de l'entendre, l'hiver au Canada devrait être plus frais et plus humide dans certaines régions et plus chaud dans d'autres. Je montre ici une carte des anomalies de température de la surface de la mer, les différences par rapport à la normale. Il y a trois tendances importantes. Premièrement, nous sommes en présence d'une faible La Niña. C'est le cinquième événement La Niña au cours des 6 dernières années. Il se manifeste par des anomalies froides de température de surface de la mer dans le Pacifique équatorial. Ensuite, nous avons la phase négative de l'oscillation décennale du Pacifique, le ODP, représentée ici par les anomalies chaudes dans l'intérieur du Pacifique Nord. Enfin, nous avons des températures de surface de la mer plus chaudes que la normale dans la baie d'Hudson et l'Atlantique Nord-Ouest. Les deux premiers facteurs affectent principalement l'Ouest canadien, bien que leurs effets puissent s'étendre jusqu'au Grand Lac. Il entraîne des hivers plus humides et plus frais dans l'Ouest et pourrait conduire à avoir davantage de neige à effet de lac dans la région des Grands Lacs. Le troisième facteur, les températures de surface de la mer plus chaudes que la normale, causent un retard dans la progression de la glace et également des températures côtières plus chaudes dans la région de la baie d'Hudson et de l'Atlantique Nord-Ouest. Ce troisième facteur est lié au réchauffement climatique et non pas à la Niña et à l'ODP. Prochaine diapo, s'il vous plaît. En ce qui concerne le réchauffement climatique, je montre ici un graphique de la température hivernale moyenne au Canada entre 1948 et 2025. Ce que nous voyons dans ce graphique, c'est que les températures hivernales moyennes ont augmenté de 3,7 degrés au cours de cette période. Ce réchauffement est toujours un facteur important pour la prévision saisonnière hivernale, compensant partiellement l'effet du refroidissement de la Niña et de l'ODP. Ce réchauffement climatique fait en sorte que les vagues de froid extrêmes se produisent moins souvent et sont aussi moins intenses. Prochaine diapo, s'il vous plaît. Je vais maintenant vous parler du système canadien d'attribution rapide des phénomènes météorologiques extrêmes que nous utilisons pour déterminer comment la probabilité des épisodes de température extrême, comme les vagues de froid et les canicules, est affectée par le réchauffement climatique. Désormais, nous pouvons également utiliser la version pilote de ce système pour les précipitations extrêmes, dont la plupart tombent sous forme de pluie abondante au Canada. Les épisodes de précipitations extrêmes devraient devenir plus fréquents et plus intenses en raison des changements climatiques liés aux activités humaines. Cependant, comme nous pouvons voir sur la carte des quantités annuelles maximales, les quantités de précipitations extrêmes varient à travers le pays, selon le système météorologique qui les cause. Sur la côte ouest, une région affectée par les rivières atmosphériques, cette quantité peut dépasser 200 mm par jour à certains endroits. L'est du Canada et les provinces maritimes, où les tempêtes les plus intenses sont des dépressions ou des ouragans, peuvent également recevoir de grandes quantités de pluie. En revanche, dans le nord canadien, le maximum annuel peut être aussi bas que 10 mm par jour. Il est donc important de considérer cette variabilité géographique. Prochaine diapo, s'il vous plaît. Le système canadien d'attribution rapide des phénomènes météorologiques extrêmes détermine comment la fréquence des phénomènes météorologiques extrêmes a changé au cours des dernières 150 années en raison de l'activité humaine. Cela se fait en utilisant des données de modèles climatiques pour calculer comment la chance qu'un événement extrême se produise dans le climat actuel avec l'influence de l'activité humaine se compare aux chances que l'événement se produise dans le climat pré-industriel, avant le réchauffement climatique. Ceci est illustré dans le diagramme à droite pour les canicules. Le climat actuel, représenté par la courbe rouge, est décalé vers des températures plus chaudes que le climat pré-industriel, la courbe bleue. En conséquence, un événement d'une certaine magnitude se produira plus souvent dans le climat actuel que dans le climat pré-industriel. L'air surligné sous la courbe rouge est plus grand que l'air surligné sur la courbe bleue. Prochaine diapo, s'il vous plaît. Une fois que nous calculons le changement dans la chance que l'événement se produise entre le climat actuel et le climat pré-industriel, nous exprimons le résultat sous forme d'énoncés de probabilité. Par exemple, si un événement est de 2 à 10 fois plus susceptible de se produire en raison du réchauffement climatique, nous disons que l'événement est beaucoup plus probable. Les couleurs chaudes sur le cadran correspondent aux événements dont la probabilité de se produire augmente en raison du changement climatique d'origine humaine, comme les canicules ou les événements de précipitations extrêmes. D'autre part, les couleurs froides correspondent aux événements qui sont moins probables en raison de l'activité humaine, comme les vagues de froid. Exprimer l'information que le système fournit en termes d'énoncés simples donne aux Canadiens un aperçu direct de la façon dont le réchauffement climatique affecte nos vies et notre météo aujourd'hui. Prochaine diapo, s'il vous plaît. Donc, comme pour les épisodes de température extrême, les événements de précipitations extrêmes sont analysés sur des régions prédéterminées. Cependant, étant donné que les extrêmes de précipitation se produisent à des plus petites échelles spatiales que les extrêmes de température, le système de précipitation utilise 89 régions plus petites, incluses dans les 17 régions du système de température montrées sur la carte à droite. Bien que la plupart des précipitations extrêmes au Canada soient des pluies abondantes, dans sa forme pilote, le système considère tous les types de précipitations, pluie, grésil, neige, pluie verglaçante et grêle ensemble, en raison des données d'observation et de modèles que nous utilisons. Le système fonctionne tous les jours et les résultats sont disponibles le jour suivant l'événement. Prochaine diapo, s'il vous plaît. Et voici un exemple de comment le système fonctionne. Nous présentons un épisode de pluie abondante causé par le passage de l'ouragan Melissa sur l'est du Canada. Vous pouvez voir ici des cartes de précipitations quotidiennes sur l'est du Canada pour le 31 octobre et le 1er novembre. Le système compare la quantité moyenne de précipitations quotidiennes sur chaque région, montrée dans les cartes plus bas, à la valeur climatologique des précipitations quotidiennes extrêmes sur cette région. Si la valeur climatologique est dépassée, un événement est détecté et nous effectuons l'étude d'attribution. Si la valeur climatologique n'est pas dépassée, nous n'avons pas d'événement extrême. Pour les précipitations de l'ouragan Melissa, le seuil a été dépassé pour 3 régions et donc d'événements de précipitations extrêmes ont été détectés le 31 octobre et le 1er novembre sur le centre sud du Québec, Saguenay-Lac-Saint-Jean et l'est du Labrador, Happy Valley-Goose Bay. L'analyse d'attribution de ces 3 épisodes a montré que les événements au Québec étaient plus probables en raison du réchauffement climatique lié aux activités humaines, tandis que l'événement au Labrador était beaucoup plus probable. Prochaine diapo, s'il vous plaît. Donc, le système fonctionne et fournit des résultats d'attribution depuis juin 2025. Nous avons détecté 42 événements dans des diverses régions au Canada, comme vous pouvez le voir sur la carte. Parmi ces épisodes, 3 étaient beaucoup plus probables, tandis que 39 autres étaient plus probables en raison du réchauffement climatique lié aux activités humaines. Nous continuerons à surveiller les événements météorologiques extrêmes en utilisant ce système. Ce domaine de recherche soutient une prise de décision importante qui aide les communautés canadiennes à se préparer et à s'adapter aux changements dans la fréquence et la gravité des phénomènes météorologiques extrêmes. Sur ce, je vous remercie pour votre attention et je redonne la parole à Jennifer.
Merci, Madalena. Alors qu'on approche la fin de la séance, je vais prendre un moment pour vous parler de notre nouveau système d'alerte météo par code de couleur. Nous avons mis à jour notre façon de partager les alertes afin qu'elles soient plus claires et plus utiles. Nos alertes mettent l'accent sur ce que le météo va faire et pas seulement ce qu'elle sera. Elles mettent en évidence les impacts possibles et vous aident à savoir comment et quand agir pour vous protéger, ainsi que vos proches et vos biens. Pour rester au courant des conditions qui changent, vous pouvez télécharger l'appli MétéoCan pour recevoir des notifications en temps réel ou consulter les alertes en tout temps sur canada.ca/météo. Diapo suivant. Avant de conclure, un petit rappel pour vous aider à bien vous préparer cet hiver. Quelques gestes simples pour faire une grande différence pendant une froide extrême ou une tempête. Assurez-vous d'avoir une trousse d'urgence prête. Gardez vos appareils chargés en cas de panne d'électricité. Préparez votre véhicule pour l'hiver. Restez informé en suivant les prévisions et les alertes. Restez restez eau chaude et limitez le temps passé dehors lors des froids extrêmes. Habillez-vous en couche et couvrez le pot exposé. Et pensez à prendre des nouvelles de vos voisins, amis et membres de la famille. Et pour plus de conseils, vous pouvez visiter préparez-vous.ca pour rester en sécurité et prêt à faire face à ce que l'hiver nous apportera. Diapo suivante. Simplement, merci de votre attention. Restez prudente et profitez bien de l'hiver.
OK, merci Madalena et Jennifer pour cette présentation. Avant de passer aux questions, j'aimerais ajouter que Dr. Megan Kirschmeyer-Young, chercheuse en climatologie, sera également disponible pour la séance des questions-réponses. Thanks, Madalena and Jennifer for the presentation. Before we turn to questions, I'd like to add that Dr. Megan Kirschmeyer-Young, a climate research scientist, will be available for the Q&A segment, which will begin now. Veuillez utiliser la fonction main levée si vous avez une question. Nous vous demandons de vous tenir en une question et une question de suivi. Nous vous prions de vérifier que vous êtes en mode mouette lorsque vous ne posez pas des questions. Les combinaisons de touches suivantes peuvent être utilisées sur votre clavier de numérotation. Étoile 6, couper, établir le son. Étoile 9, lever les mains. Please use the hand-raising function if you have a question. We ask you to keep it to one question and one follow-up. We kindly ask that you ensure your line is muted if you are not asking questions. The following commands can be entered using your phone's dial pad. *6, toggle mute, unmute, and *9 for hand-raise function. Okay, the first question is from Ted Henley, CBC News. Go ahead, Ted.
Oh, sorry, Samantha, can you hear me now?
I can. Okay,
Okay,
go ahead.
good. Thank you, Samantha, Jennifer, and Madalena. I appreciate all the information this morning. I'm with CBC News in Calgary, Alberta. I'd love to focus in on southern Alberta if I could here. And I'm wondering, Jennifer, if you can talk about what Environment Climate Change Canada is seeing for this winter, precipitation-wise, temperature-wise, and of course, the likelihood of Chinooks, as we love Chinooks in this part of Canada. And Madalena, if you could talk about the chances of extreme weather this winter for southern Alberta, please.
Great question. Thank you, Ted. Okay, so looking at, if you're recalling the maps from the presentation, the temperature forecast was is a little bit up in the air, right? The map was covered in white in that part of Canada, and that's just because there's a lot of competing factors at play in terms of determining what kinds of temperatures we're going to see this year. We've got factors which I think Madalena can probably speak to more than I can, but we've got factors like La Nina playing a role to keep things cooler. It's very, very classic signal signature is seeing colder temperatures over Western and Northwestern Canada, which includes Southern Alberta in that during a La Nina season. We've also got a current event that's ongoing where we've got a very cool snap that's going to be moving into Alberta tonight and in through the weekend coming into play. And that's thanks to a destabilized polar vortex and a nice deep trough that's allowing that cold Arctic air to plunge south, certainly for the short term of the season. But longer term, it's hard to say. We've got competing factors like climate change and just a warmer environment to work with, to contend with, to balance that out. So it's hard to say what the temperatures are going to look like this year. But in terms of precipitation, it does seem like seems like there's a fairly strong signal so far that it could result in an above average season for precipitation. So we'll have to see how things unfold with the weather pattern itself, but that is the long-term prediction. I wish I could offer a better story for you as to how that's going to unfold and whether that's going to make for a great ski season for you. And again, when it comes to shorter range events like Chinooks and whatnot, I would love to be able to say there's going to be, a nice warm up every weekend, for you for the winter season. But unfortunately, that's a very local event that can really only be forecast in the short range. So sorry about that. Maybe Madalena, would you like to jump in?
Yes, thank you for the question. I think the question was also about how extreme events, what kind of extreme events we are expecting for this winter. I cannot talk about the forecast. I think Jennifer already did a great job in covering that. However, I can say a bit of how our system is working. So our system does not forecast extreme events, but instead we monitor extreme events as they happen. So right now we are monitoring heat waves, cold snaps, and extreme precipitation events. When it comes to Southern Alberta, I would say that for the next winter, we are not expecting to see maybe any heat events, but I think we are definitely monitoring cold snaps. And in terms of precipitation events, this analysis is ongoing, but because our system is mostly sensitive to heavy rainfall, we might not expect to see extreme precipitation events over Alberta this winter. But that being said, we are on the lookout. Thank you.
Okay, did you have a follow-up question, Ted?
Yeah, if you don't mind. And Jennifer, if you could tackle this, I'd appreciate it. I understand what you're saying regarding precipitation and chances like that, but if I needed to describe to everyone to try and categorize the temperature situation, just kind of outlook wise, are we going to be, at seasonal temperatures above or below? Is there a way to kind of nail that down at all?
I wish I could give you more information. Unfortunately, the confidence was just too low in this year's forecast. We're seeing some of that appear on the map in Canada, but nothing over southern Alberta, including Calgary, of course, to really identify what we're going to see. But the average is really just looking at the average season when you add up all of the temperatures for all of the days, that full 90-day period. So what I can really say is that it's looking like it's probably going to be on the chillier side, at least in the very short term through the next few days for sure. And it is trending to be on the cooler side at times through the month of December. But beyond that, in terms of what it's going to average out to at the end of the season, I just don't have any information, unfortunately.
Okay. La prochaine question nous provient de Julie Carpentier, Radio-Canada. Julie, vas-y.
Bonjour tout le monde. Ma question s'adresse à Madalina. J'aimerais que vous élaboriez un peu sur, nous vivons présentement une rivière atmosphérique dans l'Ouest, sur les probabilités qu'il y en ait d'autres cet hiver et nous expliquer un petit peu le phénomène là, avec ce que vous avez observé sur, si j'ai bien compris, la température au-dessus de la mer qui est un peu plus chaude.
Oui, bonjour. Merci pour la question. Donc oui, c'est vrai, nous avons un phénomène de rivière atmosphérique en ce moment sur la Colombie-Britannique. je ne peux pas vraiment dire comme c'est la saison des rivières atmosphériques en ce moment. Donc, on s'attend d'en avoir plusieurs. À chaque année en Colombie-Britannique, il y en a plusieurs événements comme ça qui se produisent à l'hiver. Donc, on s'attend d'avoir plusieurs, mais je ne peux pas vous dire exactement comment que cette prévision va se dérouler parce que comme on voit, nous avons des effets, nous avons l'effet de la Niña qui peut causer des hivers plus humides, c'est vrai, mais nous avons aussi le réchauffement climatique qui peut contrer cet effet. Donc, donc, on est dans la saison des rivières atmosphériques et on peut s'attendre d'en avoir plusieurs, mais je ne peux pas vraiment vous donner plus de précision. Quand ça vient à la prévision, peut-être que Jennifer peut élaborer. Maintenant, côté événements extrêmes, nous sommes en train de surveiller ces événements extrêmes-là et nous roulons notre système d'attribution pour pouvoir les analyser. C'est-
Oui, je peux ajouter un peu comme Madelina a dit. Les rivières atmosphériques sont des longs corridors étroites d'air très humide qui écoulent depuis les régions subtropicales vers la côte ouest. Et quand elles atteignent la Colombie-Britannique, cette humidité est forcée de monter au-dessus des montagnes, qui produit des fortes pluies et de neige abondante. C'est un phénomène normal à l'automne et en hiver. Mais la plupart de ces événements sont gérables, mais euh, quelques-uns pourraient avoir plus d'impact, comme celui-ci on a maintenant. Mais c'est une partie normale de l'hiver et de l'automne dans cette partie du Canada. Oui, les problèmes arrivent avec les rivières atmosphériques quand elles stagnent ou ils touchent la même région plusieurs fois ou elles sont exceptionnellement fortes, par exemple. Mais avec ce système, on a reçu beaucoup de précipitations, mais il y avait des impacts, mais on n'a pas la même situation comme des années passées, comme par exemple en 2021, parce que le sol n'est pas si saturé comme les années passées et ils, euh, ils ont la possibilité d'absorber une partie des premières précipitations. Donc, ce n'est pas une égalité à un événement de 2021, mais c'est un système fort qui apporte des impacts et on toujours garde un œil sur la situation et ce n'est pas quelque chose qu'on peut prévoir en avance. C'est un système comme une tempête de neige. On ne peut pas prévoir plus d'une semaine à l'avance, mais c'est normal pour cette partie du Canada d'avoir des systèmes comme ça.
Avez-vous une question de suivi?
Oui, s'il vous plaît, si c'est possible. Merci beaucoup pour vos réponses. En français, je l'apprécie. Vous faites référence, Jennifer, à 2021. À quel point cet événement-là est exceptionnel, toujours là, concernant les rivières atmosphériques, ou si on peut s'attendre, est-ce que c'est un événement comme une fois par siècle, ou on peut s'attendre dans l'avenir à ce que ça se reproduise?
Excellente question. Peut-être Madeleine a pour m'aider avec cela. Euh,
Oui,
oui, veux-tu
oui,
prendre ça,
oui,
Madeleine?
merci.
OK, parfait.
Oui, je peux le faire. Donc, oui, les précipitations liées à la rivière atmosphérique de 2021 qui ont causé beaucoup d'inondations en Colombie-Britannique, ça a été un événement extrême particulier, c'est vrai. À Environnement Canada, nous avons fait une étude d'attribution sur cet événement-là et nous avons trouvé que le réchauffement climatique a beaucoup contribué à rendre cet événement plus intense et plus fréquent. Donc oui, à cause des changements climatiques, à cause du réchauffement climatique, on peut s'attendre que des événements comme les rivières atmosphériques, comme les précipitations liées aux rivières atmosphériques, vont devenir plus intenses et aussi plus fréquentes.
OK. The next question will be from Daniel Reach, 980 CJME. Go ahead, Daniel. Oh, wait, I see Daniel dropped off. Okay, maybe not Daniel. Okay, we'll go next question from Eric Tashner. I'm sorry if I'm saying that incorrectly, from CTV Northern Ontario.
Can you hear me okay?
Yeah, go ahead.
Great. Similar to Ted's question, looking for an outlook for northeastern Ontario. What are we expecting for precipitation and temperature-wise? Thank you.
Okay, great question. Thank you. So I think we're in a similar sort of situation where we have a map that is mostly white in that area. So it's going to be tricky to be able to assign a lot of confidence to what the temperatures and precipitation will end up being by the end of the season. But unlike in the West, which Madalena can speak to probably a little bit more than I can, the effect of La Nina is not as significant as you move east in Canada. So we have less of an influence on what the outcome will be. So there's a little bit more variability with regard to temperature. But that said, we are expecting that storm track that I talked about that's kind of working its way down from the Rockies across into the Western Great Lakes. But from there, we don't really have a lot of certainty as where storms will track. They could track across northeastern Ontario. As we saw earlier, I think a couple of weeks ago, we had a very powerful storm that worked its way through the region, bringing immense snowfall to the area. The track could also continue further, it could set up further south, right? So it's not a guarantee that you're going to see more storms, but there is, you're very close to where the storm track, the path can diverge basically at that point. We don't know if it's going to track northeastward, if it's going to go east, or if it's going to go south, but there's potential for the storm track to be favorable leading up to northeastern Ontario. So unfortunately, there's not a whole lot I could say with that, other than the Great Lakes themselves are warm. Any squalls or snow systems that develop off of the Great Lakes, they do have an abundance of moisture available to them. So there could be some snowier starts to the season, but until the lakes start to freeze over, until the lakes start to freeze over, that is. Maybe Madalena would like to jump in.
Oh, thank you for the question, Jennifer. I think you did a great job. I will just add, as mentioned in the presentation, we are dealing with a weak La Nina. This might affect lake effect snow amounts over the Great Lakes region. And we have to keep in mind that we have in the backdrop, the warming climate change. So just in general, we are expecting extreme cold events and extreme to become less intense because of the global warming climate. But otherwise, the forecast as presented by Jennifer, I think, covers everything. Thank you.
Okay, did you have a follow-up question?
No, actually, all my other stuff has been answered. Thank you.
Okay. La prochaine question nous provient de Sébastien Auger, Le Devoir.
Oui, bonjour.
Bonjour.
Oui, un peu comme mes autres collègues, ben, moi, ce serait pour le Québec. Est-ce vous avez des données spécifiques de prévision pour le Québec?
Oui, bonjour. Oui, même comme les autres, je n'ai pas beaucoup à dire au sujet du Québec à cause de tout le blanc sur la carte, mais donc, je ne sais pas exactement qu'est-ce qui va se passer avec les températures, mais même comme le nord-est de l'Ontario, le trajet des systèmes pourrait affecter la région. Donc, au sujet de précipitations, l'hiver au Québec devrait probablement variable. Les tempêtes pourraient traverser le sud de la province vers les maritimes ou peut-être remonter vers le nord à travers le Québec. Donc, on ne sait pas exactement si les systèmes vont impacter même les énormes systèmes en provenance des États-Unis qui pourraient apporter des quantités de précipitations énormes pour la région, pourraient même affecter affecter le Québec aussi. On ne sait pas exactement quand ou la fréquence des événements, mais je peux simplement dire au sujet des températures qu'ils pourraient fluctuer selon les incursions d'air arctique qui se passent dans la région des fois, mais je vous recommande à vos résidents de se préparer à des conditions hivernales typiques, de neige, de froid et des périodes de temps parfois perturbées.
OK. Avez-vous une question de suivi?
Ben, je vous posais la question parce que ici on a un média qui s'appelle Météo Média et qui prévoit un hiver avec beaucoup plus de neige que d'habitude et plus froid. Je voulais voir si vous aviez vous aviez les mêmes prévisions.
Non, ouais, oui et non. La confiance est vraiment base pour nous, pour dire exactement pour la région qu'on va avoir plus de précipitations ou des températures en dessous de la normale, mais il y a des indices avec la Niña que le trajet des tempêtes pourrait affecter la région, mais on n'a pas eu la confiance de dire qu'on va avoir une saison au-dessus de la normale à cause de cet phénomène. Peut-être, Madalena, est-ce que vous avez quelque chose à ajouter? Non. OK. Désolée. On est différentes.
Okay, we'll continue to Daniel Reach, 988 CJME. Daniel, go ahead.
Hi, can you hear me okay?
Yes.
Yes.
Sorry about that. My computer restarted, so that's why I had to go out of the meeting. So I was just wondering, what can we sort of expect in Saskatchewan in terms of the broader outlook of what winter will bring in terms of what people can expect, not just only for road conditions, but snow and what levels and what kind of snow?
Oh, that's a great question. Thank you. And sorry about the computer troubles. I know that struggle well. So the conditions in Saskatchewan, I think, are going to be somewhat similar to that of Alberta, which we spoke about earlier, just in the sense that during a typical La Nina winter, we do see colder temperatures for the sort of western part of Canada, extending into northwestern Canada, kind of on the east side of the Rocky Mountains there, which would include enough east to include Saskatchewan. Now, on our map, we didn't have enough confidence to put, say, a below seasonal trend for the entire season, but we're certainly seeing that classic La Nina signature to start the season with those colder temperatures moving in, I think tonight and tomorrow into Saskatchewan with a cold spell. And I think we will continue to see some Arctic blasts and cold spells throughout the first part of the winter season, interspersed with some warm-ups there. But beyond that, it's really hard to dictate what the temperatures are going to be like. Unfortunately, I just don't have a lot of indication in the forecast to say one way or the other. So I would just be prepared for fluctuations and be ready for anything. With regard to precipitation, again, I think we've got the potential for maybe some more snowy conditions. That is sort of a classic setup again with a La Nina pattern, with the storm track traveling from the Yukon, basically draw a line from Whitehorse to Winnipeg, and sort of along that path is a very common track. It's not going to mean that every storm is going to pass by that way, but it does show an increase in that route. And so I would definitely plan for a snowier winter, and we'll see how the season unfolds.
Okay, do you have a follow-up?
Yeah, I guess just in terms of the weather systems that were impacting Saskatchewan or really Western Canada, as you spoke to earlier, is there a way in which it's having a different kind of effect than we might see in a normal winter?
Oh, that's a very good question. I don't know about weather systems per se. If you're sort of referring to the cold air that we're getting, the sort of blasts of winter, the early start to the season, that is definitely something that is kind of feels like an artifact of winter of the past. It's not something we've seen for a while in parts of Canada. I don't have a lot of data yet on the prairies per se, because a lot of that cold air, we had that one spell sort of around the 5th, 6th of December, but we haven't really gotten into the cold that's coming in now. But certainly if I were to refer to, for example, up in the Yukon, they haven't seen a winter this cold in many years. I just have to check my notes here for a second for the exact dates, but just looking back, yeah, it's not been since basically 1983, give or take, since we've had a cold winter this this early in December in that part of Canada. And some of that cold air will be working its way into the prairies over the next couple of days. So Saskatchewan is definitely going to see some cooler temperatures, and it's something we haven't seen for this early in the season for many parts of Canada in quite some time. That said, it's not record-breaking cold. It's just colder than we're used to seeing recently.
Okay. The next question is for Jordan Olmsted, the Canadian Press. Go ahead, Jordan.
Thanks for taking my question. I was just hoping, Jennifer, you could comment a bit more on the conditions that we're seeing in BC. I know that you kind of mentioned it in French, but hoping you could do so in English as well. Like how exceptional are these conditions that we're seeing in this atmospheric river? And would you kind of call this generational when we talk about flood conditions happening once in a century or so? And yeah, just hoping for you to expand on the conditions that we see right now.
Yeah, for sure. No, that's a great question, and happy to discuss what I know at this point. A lot of it is ongoing right now, so I don't know how much we know about where this event will stand in terms of its overall impact. But it is it is showing some impact so far. We've definitely seen a lot of rainfall into the region. For example, anywhere from around 50 millimeters. You've got 47 millimeters in Vancouver Harbor, West Vancouver, much higher amounts in the Fraser Valley, where rainfall totals are over 100 millimeters in that region. And that was just, that's reported as of 4 a.m. Pacific time today. So we've got, Hope Airport saw quite a lot with 140 millimeters falling in Victoria. 62 millimeters in Victoria. There's just been significant rainfall, as you noted, in recent times. This is, of course, due to an atmospheric river affecting the region. It was a lot of rainfall in a very short period of time, which, of course, can be impactful. A lot of the region has been dry through much of the fall season. So it does still have some capacity to absorb some of the moisture, unlike previous events, which I was previously giving an example in reference to in 2021, where soils were very saturated. We'd had a succession of rainfall events leading up to the big event in 2021. And so it made it much harder for soils to absorb any of the moisture in the region, combined with, of course, burn scars from wildfires in the area. So this time, we are seeing significant rainfall. It is showing some impacts in the Fraser Valley area. I think flooding is more of a provincial domain, so I don't want to dabble too far into that, but there have been some reports of some flooding in the region as a result of the rainfall. So it is impactful. I don't know where it falls in the scale of impact of events. I don't know if, Madalena, you guys have started doing any analysis on this one that you want to jump in on?
Yes, I think I can add a little bit to it. So, in fact, these atmospheric river events are quite common. They do happen. We have several of them every winter, and they do cause localized flooding. According to us, so the rapid event attribution system is analyzing all of these events, is analyzing extreme precipitation. And actually, the event that just happened yesterday, for yesterday's precipitation, we haven't triggered an extreme event over that region, because while it was very intense at certain location, compared to the climatological value of extreme precipitation over that region, it was not intense enough. So in our system, we are not detecting it as an extreme event. So events of this type are common over this time period. And having analyzed other events of this type before, we do know that climate change and human-induced climate change has an effect on them. So these atmospheric river events are becoming more intense because of human-caused climate change. Also, the event of yesterday most of the intense precipitation associated with it actually fell just on the other side of the border in Washington State.
Maybe as a quick follow-up to that for Madalena, you mentioned that it's not necessarily this system hasn't been triggered for this event. Do you expect that it might? You know, we're still seeing some rains today, and how could this this system offer kind of what is the benefit when it's applied to a system like we're seeing in BC right now?
Yeah, so it's a bit of so here is where we have to compromise a bit with the system. So what happens is that the precipitation that happened was very strong, but was very localized. If you remember in my presentation, I had a map of precipitation, and you could see that over the Pacific coast, we have very intense rainfall, climatological extreme rainfall. So it is very difficult to yes, we have very intense rainfall. So the system right now looks over 89 different regions over Canada and looks at average precipitation over those regions. And the reason why we do that is because we do not necessarily have confidence in our climate model data to be able to go at smaller scale, so to look at more localized systems. So, you know, this is a research project, so we are continuously working on it, and we are hoping to be able to, you know, offer more results in the future. This being said, we have analyzed, the environment researchers at Environment Canada have analyzed atmospheric river events such as this before, such as the 2021 floods. And we do expect human-induced climate change to increase the frequency and the intensity of such events.
Okay, we will continue to the next question to Andrew Wah, Telegraph Journal. Apologies if I'm saying your last name wrong. Andrew, go ahead.
Sorry, can you hear me now?
Yes.
Yeah. Okay, thank you. Sort of along the lines of some of the other questions, I would like to get some insight specifically into New Brunswick's winter, if possible, please. And whoever wants to take that question, that's great. Thank you.
Thank you for the question. Okay, so with regard to New Brunswick, looking at our reference maps, again, we're not seeing a lot of strong indicators one way or the other with regard to precipitation or temperatures this year, which makes it very tricky to offer a confident story for what the winter might be. Again, similar to, I think, Ontario and Quebec, again, with where the storm track is going to end up, will probably play a role in terms of how much precipitation the region sees. We've got a very active storm track that has been crossing the Great Lakes and tracking basically east into, you know, Eastern Ontario, Southern Quebec, and into New Brunswick. We've seen that sort of rhythm so far for the last few weeks as we've trended into the winter season. So that is a possible setup. Of course, the storm track can also go south of New Brunswick, and it could also go, you know, track to the north as well through the season. There's, of course, the high variability of the big storm events that can develop in the States. New Brunswick, if it does, you know, if systems that develop off the coast of the Carolinas, for example, venture up the coastline, if it does track far enough west, then it can bring some impacts into New Brunswick as well. They tend to be very large systems with wide-reaching impacts. Those are still on the table this year, but unfortunately not something that we can predict, you know, much more than a week in advance. So I don't have a whole lot that I can offer in terms of what the season will look like. And as I think Madalena can probably attest to as well, is the impact or the story that we can glean from a La Nina pattern becomes much more muted as you go east across the country. So we don't have as much in the way of confidence or indicators to help tell that story as well. So I don't know if Madalena, you want to jump in, but there's unfortunately, I wish I could tell you more, but it's just a very low confidence forecast this year.
Okay, did you have a follow-up question?
Yeah, actually, I would like to hear from Madalena about that, and specifically the sea surface temperatures. That'd be great. Thank you.
Okay, thank you. Yes, so we are seeing. So I think Jennifer covered very well the seasonal forecast. So when it comes to the sea surface temperatures, we do see a warm sea surface temperature anomaly over the Northwest Atlantic right now. So this is affecting, but this is primarily affecting the coastal regions. So we do see that this is causing warmer temperatures on the coastal regions and also is delaying the ice progression. I hope that.
We will continue to our next question with Amarichi Amadik up for the Toronto Star. Apologies if I've said that name incorrectly.
Hi, can you hear me?
Yes, I can.
Yeah, close enough, close enough. I'm Arachi. Thank you for taking my question. Yeah, just the same with the other guys here. You mentioned something about Northern Ontario already, but I'm just wondering if you could speak a little bit to Southern Ontario. There was quite the snowfall yesterday in Toronto. I believe there was like 200 collisions between the Greater Toronto Area and Hamilton. So I'm just wondering, and I think that was due to something called the Alberta Clippers. So I'm just wondering if you could speak to that and if we can expect more of those kind of conditions through the winter, or yeah, just a general just general information about what to expect in Ontario.
Great, thank you so much. No, great question. Absolutely. So the winter storm or the winter snowfall event that we had through southern Ontario is it's actually a great example of one of those storm tracks, right? It's called an Alberta Clipper because it generally forms on the east side of the Rockies, in Alberta, and then it zips along pretty quickly. So it goes at a pretty good clip. So that's kind of how it gets its name. It's usually a faster moving system. It generally doesn't produce huge amounts of snowfall, but in this case, it did seem to produce enough snowfall to cause some impacts in Toronto and Ottawa and Montreal, basically all along the 401 corridor there. And so that's sort of in line with this classic pattern that we're expecting this year of the storm track. I just don't, you can't guarantee that every storm that's going to work its way toward the Western Great Lakes is going to pass through Southern Ontario specifically, but it's something to watch out for. I think the bigger thing for Southern Ontario is that the Great Lakes are wide open. We've got a great potential for snow squalls setting up. I know that doesn't necessarily reach Toronto per se, and they can be very, very localized where those bands set up. But there's great potential for a lot of precipitation, especially a lot of snowfall in the early part of the season, right along the shores of the Western Great Lakes in the Snowbelt region. Until the lakes start to cool off and start to freeze over, we're going to likely continue to see regular snow squall events in the region. And this is usually in the wake of those types of clipper events that we're seeing when we get winds setting up from the northwest side on the sort of the back side of the weather system as it tracks along to the east. So that was a very classic setup that we lived through yesterday, and I wouldn't be surprised to see more of them through the winter. I just don't know how many.
Okay.
Can you hear me?
Yes, please go ahead with the follow-up.
Yeah, so just from my own understanding, I'm not too sure about La Nina. Can you just explain a little bit more about that? And I believe you said that the further east you go, it's hard to say how it's going to affect the temperatures. Can you just speak a little bit more to that? And also I forget what you guys called it. Yeah, the attribution system. Can you just, in layman's term, please just like explain exactly what that entails? Because that's quite new to me.
Madalena, do you want to jump in on this one and give a little bit of explanation of La Nina in the east and some other factors that might play a role?
Yes, sure. So
Great,
so in terms of La Nina, so the La Nina effect is manifested mostly in Western Canada. Now we can see a bit of effects all the way to the Great Lakes regions, but as we move eastward, the effects are more uncertain. So that's about what we know about that. Now about the extreme, the weather event attribution system, yes, I can tell you. So the idea here is that when an extreme event happens, we are looking at how the chances of this event occurring are changing because of human-induced climate change. So by using climate model data, we compare the probability of this event, the chance of this, the likelihood of this event occurring in today's climate when we have the human influence on the climate with the likelihood of that event happening in the pre-industrial climate, when we didn't have any human influence on climate. And we compare these two likelihoods. And for a lot of extreme events, such as heat waves or extreme precipitation events, what we are finding is that the chance of these events happening is increasing because of human-induced climate change. Whereas for other extreme events like cold snaps, we find that these events, the intensity and the frequency of cold snaps, for example, over Canada, is decreasing because of human-caused climate change. Thank you.
If there's nothing else to add to that question, ceci conclut la séance d'information. Merci beaucoup. This concludes today's information session. Thank you. Thank you, everyone. Goodbye.